The area of a square is 81 centimetres squared, and we're asked to find the perimeter of the unshaded portion. Well, this is a neat little puzzle, I think, but as with all geometry questions, really, or most word problems, especially those that are about something related to geometry, you have to really think about what is meant by the special maths words that they use and how that might help you, how the things that you should know might help you use the information that's given. Let me explain. Right, the area of a square. How do we calculate area? Well, area is the flat shape inside, the flat space inside a 2D shape. If I give you the example of a rectangle first, let's do area. I'm going to write down the area is calculated by multiplying the length times the breadth. This is how you normally see it written. This refers to length times breadth. What does that look like? Well, here is a rectangle, and with this rectangle has sides. This is 2 centimeters. This is 3 centimeters. I'm not putting in the units. And if I wanted to calculate the area, I would multiply 2 by 3, or actually 3 by 2. Does this matter? No, it doesn't matter because both equal 6 centimeters squared. Okay, and I've just done this both ways round to show you that you needn't panic too much about which is length and which is breadth. Okay, it's one side multiplied by the other side. We'd normally regard, obviously, the longer side as being the length. Okay, so that's a rectangle. What about a square? We have to think. And sometimes when, you think, oh, I know what a square is. I've known what a square is since I was 2 years old. You have to think about what does it mean to be a square? What's special about a square in maths and connected to area? Well, if we think about it, a square has 4 equal sides. That's what's special here. And here we are multiplying sides. So in this square, let's say each side is 3. Okay, this is also 3. This is also 3. If I want to calculate the area, all right, I am going to do 3 times 3, the same number multiplied by itself. And here, that's 9 centimeters squared. So this is what's special about a square in relation to area. To get the area, you have to multiply a number by itself. So if we go back to this bit here, we are told the area is 81 centimeters. So something times the same number, okay, equals 81. That is the puzzle that we have, okay? And you probably know your square numbers. If you don't, they are important to learn, but hopefully you know that 81 is the product of 9 times 9, okay? 9 times 9 is 81. And if this is 81 centimeters squared, then this is 9 centimeters, this is 9 centimeters. And you know then that each length of this square must be 9 centimeters. Okay, we will put that on here in a moment. Let's just look at this bit as well. It says find the perimeter of the unshaded portion. Well, this is just, you need to know what perimeter means, and that's the outside boundary of your shape. So in this case, it's the unshaded portion. So we want to know this length plus this length plus this length and this length and this length and this length. And we simply need to add them all together, and that is going to give us our answer. All right, so the pink bit is the question mark. All right, that's the perimeter. Right. Well, I think we can get on with this now. There's only one other thing that I'm going to tell you. Have you noticed these marks here? Okay, what do they mean? Well, we'll start with this one, this single line here. When we see something like this on a shape, it means that somewhere in this figure there's going to be another, at least one more line that has the same single line mark. Okay, and that's over here. And it means that these two are the same length. All right, so this bit is the same length as this bit. And I think you'll guess then what this means is here we've got two marks here. We need to find a matching line, and there could be more than one, but in here there's only two. It means that these two lines are the same length exactly. All right, and now I think you have everything you could possibly need to calculate this. So pause if you want to give it a go before I continue. Okay, so what have we found out so far? We have found out that the length of each side of this square must be 9 centimeters. Okay, so here, all right, this is 9 centimeters. All right, and if this is 9, so's this, so's this, so's this. In fact, I'll do it on this dimension as well. Okay, so, right, 9 centimeters. Okay, well, how does this help us? Well, this is 9, so this is 9. In fact, I'll just do it here too. And here you can maybe visualize, this is like a bar model on its side, where we're now told that the total length of this line here is 9. And it's divided into two parts. This is one part. This is the other part. Okay. And if this part is 7, as is labeled here, then this part here must be 2. All right. So this is 2 centimeters, this bit here. All right. There we go. And remember this mark here. If this bit is 2 centimeters, so is its matching line over here. This bit is 2 centimeters. And again, if this is 9 and this is 2, well then this bit must be 7. Okay. So this is getting good. Right. So we now know, what do we know? We know that this is 9. We know that this line is 9. We know that this line is 2. We know that this line is 7. Okay. What else? What haven't we got? Well, we haven't got this one nor these two. Now, these two, it depends on your experience whether you can see this immediately. I am going to, some of you might spot it straight away. But here you can imagine if this is the same as this, if these are equal, and you can see now what sometimes some people find difficult is the fact that this line is up here and this line is down here. Imagine we're going to draw a line all the way down, and imagine we push this line all the way up here. Okay, imagine it was up there. I think hopefully you could then see. So we're just going to up here. All right. Just imagine it's there. And then you might more easily see that these are half of this 9 centimeters. All right. With a little more experience, you'll see it very easily if this wasn't immediately obvious to you. So this line is half of 9, which is 4.5. Okay. So this is 4.5 and this is 4.5. Okay. It's got very thick. Have we got everything yet? No, not quite. We still need to find this line. And again, it's a similar sort of situation. Okay. you have to just think, I've got this line here, this this length. If you imagine this as a length, what is this length? This total length is 9 centimeters. Okay. And this length, of course, is the same as this length, which is 2. All right, that's 2. And the same here, that's 2. All right. And if this is 2 and this is 2, all right, if we add them together, they are 4. What's 9 take away 4? Well, that gives us 5. So we now know the length of this side. So I think we can start to add things up. You need to pick a place to start. Let's say I start here and go round. I've got 9 plus 2 plus 4.5 plus 5 plus 4.5 plus 7. Okay, and you just need to add all of those up whichever way you might like to do it. Of course, you know that this 4.5 and this 4.5 together are 9. You could put these then 2 9s together and just add them up any which way you like. You could make a column addition out of it if you like. It's probably not going to make much difference, but just add them up carefully. All right, and then you are going to be able to find the perimeter of the shape, which is a grand total, oh, where's my pen gone, of 32 centimeters. Okay, so I don't think anything about this is difficult. With a little bit of experience, you will see. It's just I know from tutoring that sometimes children can't see this, and you know that this line is the same. It's the same down here as it would be up here. That can be a bit tricky sometimes, but with a little bit of practice, you can easily find out, have quite a neat little puzzle to get on with. But you just do have to think about what all of these words mean and therefore what they are telling you. What is it that you can work out?